In this video, we're going to graph linear equations utilizing the table method, or often called graphing linear equations by finding points. So, as I said in my previous video, we're going to look at a couple of different methods to graph lines. One is the table method, or graphing by finding points. The other is graphing using the slope-intercept form. This video is about the table method or finding points method, and there will be another video linked in the description about the slope-intercept form. So what I call the table method, other people will call finding points method, is pretty simple to understand. We know that when we are graphing a linear equation, the solutions are going to form a line. That is, graphing a linear equation in two variables creates a straight line when we graph those solutions. So the table method, or finding points method, says, let's find a few points. Once we found a few points, we're going to plot those, and then we're going to see the pattern. We're going to see where the line should be. Once I see the pattern, then I draw the line. So that's it. We find a few points. From those few points, we see the pattern, and then we draw the line. Now, finding points algebraically is going to consist of just picking a numerical value for either x or y, plugging in that number for x or y. Let's say we picked a number for x. We plug in that number for x. We solve for y, and that gives us an ordered pair. A lot of times I call this the table method because when I do this, I often create a table with x in one column and y in another column, and I will just list out a bunch of different values for x. So let's look at this example. This example was the one we dealt with in the previous video. Y equals 3x plus 4. So what I would normally do is I would create a table. I would list out a bunch of different x values and then use those to find y values. Now I've already done that, so I'm just going to create the table. If I plugged in an x value of -3, 3 times -3 plus 4 would yield a y value of -5. That means the point -3, -5 is a solution to this linear equation. And that means the point -3, -5 is a point on the line. 1, when I plug in the number 1, 3 times 1 plus 4 yields a 7. So 1, 7 is a solution and a point on the line. If I plug in 0 for x, it turns out you get a 4 for y. If I plug in -1 for x, you get a y of +1. If I plug in 2 for x, you get a 10 for y. And if you plug in -2 for x, you get a -2 for y. So I've already calculated these. This gives us 6 different points we can plot. I've plotted those already on the Cartesian coordinate plane or on the XY grid. As you can see, there's a pattern here. all of these points fall in a straight line. So what I would do is I would connect all those dots with a straight line and extend that straight line forever. So that's how you would get the graph of y equals 3x plus 4. Let's do another. Here's another line, y equals negative 1/2 x plus 2. And I'll go through this one a little bit slower. So I'm going to create a table, and in Microsoft Word, you can just simply create a table with x's and y's. It really doesn't matter what the table looks like, what the table, what format it is, but just need to have x values and y values listed out in your table. So I'm going to plug in some different x values. It really doesn't matter what x values you use, but if I look ahead, I have a denominator of 2 here. And so if I multiply by x's, which are even, that'll kind of get rid of the denominator and give me nice integer numbers. So most of the x's that I'm going to plug in are going to be even numbers. It doesn't have to be that way. So let's plug in an x value of negative 4. Let's see how this is done. So I take my equation and I replace the x value with a negative 4. That will give me a y value, which is negative 1/2 times negative 4 plus 2. I can type that into my calculator, or we can do other things. You can just do it by hand as well, obviously. What you end up with is a y value of 4. Not sure why that is bolded, so I'll unbold that number. In fact, all of them are bolded. Huh. So that yields the point negative 4, 4. Then I go back and I say, well, let's do another point. Let's start with the x value of 0 this time. I simply change the x value to 0 in my equation, or insert 0 in for the x value in my equation, and that will yield a y value of 2. Again, I'm just typing in negative 1/2 times 0 plus 2 into my calculator, and that gives me an equation that says y equals 2. Let's plug in some other numbers. Let's plug in the number 2 into the equation. So y equals negative 1/2 x plus 2 becomes y equals negative 1/2 times 2 plus 2. That gives me a y value of 1. If I did plug in an odd number, that's perfectly fine. It's not going to hurt anything. Negative 1/2 times 3 plus 2. So let's plug in the x value of 3. I forgot to write that down. If I plug in an x value of 3, negative 1/2 times 3 plus 2 gives me a 0.5 as my y value, or a 1/2. I am not particular about whether you use decimals or fractions here. Some people may be. but that's on them. So I'll use 0.5 or 0.5 there. Let's plug in another x value. Let's plug in the x value of a positive 4. If I plug in the x value of positive 4, negative 1/2 times positive 4 plus 2 gives a y value of 0. And then let's plug in, let's say, a positive 6. Plugging in a positive 6 for my x value gives me a negative 1/2 times 6 plus 2. That gives me a negative 1 as my y value. Now I just kept replacing here the x value with a different one. If you're doing this by hand, you'll probably, have lots of these things written down, and that's perfectly all right. Now I have 6 different points. So I have the point negative 4, 4, 0, 2, 2, 1, 3, 0.5, 4, 0, and 6, negative 1. So we're going to graph all 6 of those points. I'm going to do this by hand this time. So I will show you how that works when you graph it by hand. Now, by hand, I'm going to utilize paint, I guess. So negative 4, 4 as a point means I have to go left 4 units and then up 4 units. And I get a point right there, negative 4, positive 4. 0, 2, 0, 2 gives me this point here. 2, 1 gives me this point here. 3.5 gives me this point here. 4, 0 gives me a point here, roughly, kind of do that low. And then 6, negative 1 gives me a point right there. So we can easily see the pattern that we have. And if we want to draw a line, we would simply connect all those dots. And technically, you're supposed to extend the line forever to the left and forever to the right. Obviously, we can't draw an infinite line. It would take infinitely many seconds to do that. So instead, oftentimes, we just draw arrows at the end just to indicate that this pattern goes on forever to the right and forever to the left. So that's how we graph a line by finding points. Now, obviously, I found 6 points for this line. You don't always have to find 6 points. You can find 2 points actually determines a line. But oftentimes we like to do at least 4 points just so we know that we didn't make a mistake. So 2 points technically determines a line where the line should kind of go through. But oftentimes we like to do, at least 4 or more points just to make sure our pattern is correct. Let's look at another example. Here we have example 3, and we're asked to graph 5x minus 2y equals negative 8. So this one obviously is different than our previous one because our previous line, our previous equation had y equals on one side. So it was really easy to plug in values for x. Now we have 5x minus 2y equals -8. You can approach this in a couple of different ways, and I'll show you both. Okay, so the first option is exactly what we did last time. We take the equation as is, and we plug in a value for either x or y. It turns out it doesn't matter which, if you plug in for x or you plug in for y. Let's say we plugged in a value for x of -4, okay? Well, then I would go to my equation directly, 5x minus 2y equals -8, and I'd plug in -4 for x, and this gives me an equation that I can solve for y. When I do that, we'd solve it in the normal way. -20 minus 2y equals -8. Adding 20 to both sides gives me -2y equals a +12. Again, we have to add 20 to both sides. And then lastly, I divide both sides by a -2, giving me y equals -6. So the point -4, -6 would be the point on the line. Now, that's not the only way we could have done that. Notice that it took me a long time to solve this for y. And the next time I plug in a value of x, let's say I plug in an x value of 0, for instance, I'm going to have to go through the same process. So another way to deal with this is to solve for y right up front. In other words, solve for y before I start plugging in these numerical values for x. So that's what I'm going to do. I'm going to subtract 5x from both the left and the right-hand sides. That will give me, on the left-hand side, just a -2y or a -2y. On the right-hand side, if I subtract 5x, I get -5x minus 8. Then what I can do is divide both sides by -2. If I divide the left-hand side by -2, I just get the y. And if I divide the right-hand side by -2, -5 divided by -2 is the same as 5/2. So I get 5/2 x. And if I divide the -8 by a -2, I end up with a +4. So if I wanted to, I could rewrite this line, solve it for y, and then start plugging in the x values. Now, if I start plugging in the x values, it might take me a little bit less time to figure out what my y, my corresponding y would be equal to. For instance, if I plugged in a -4, I can simply now type into my calculator 5/2 times -4 plus 4 and get a y value of -6. If I plug in an x value of 0, I get a y value of 4. And again, that's a very quick and easy process. That means this line goes through the point 0, 4. By the way, I'm only going to find 5 points this time rather than the 6 points that I found in the last example. let's plug in a value of, let's say 1. If I plug in an x value of 1, 5/2 times 1 plus 4 gives me 6.5 or 6.5. Let's plug in a value of, let's say, -2. I've only done one negative so far. If I plug in a value of -2, I'll type it in here, -2 plugged in, yields a -1 as my y value. So if I plug in a -2, simplify that, I get a -1. And then let's plug in, I guess, a +2. So plug in a +2, and what you'll end up with in terms of your y value, 5/2 times 2 plus 4 gives you a y value of 9. If I'm doing that very fast, again, hopefully you can keep up with that. But if it is too fast, obviously you can slow down, push pause, check that you do indeed get a y value of 9. And so that kind of process where I solve for y first and then plug in numbers, oftentimes that makes the problem go by a little bit quicker. But if you wanted to, you could have plugged in 0 or 1 or -2 or 2 into that original equation and solved it. So let's graph this. I'll again graph this in blue. Again, it doesn't matter what colors this is, but so -4, -6, -4, left 4, down 6. I think we get this point here. 0, 4 gives you that point there. 1, 6.5 gives you a point which is about there. -2, -1, 2, 9. So there are the 5 points that I've chosen. By the way, sometimes you may have chose an x value where it's off a grid that you're trying to place the line on. That's perfectly okay. Just pick another point if you want, or you can just use, if we started with 5 points, you can just use the 4 points that we have. So here we go. We have a line going through all those points. This is not perfectly drawn, but you can see the idea. And then again, I like to draw arrows at both the top and bottom, at both the left and right, to indicate that this line goes on forever in both directions. So this pattern, it goes on forever in both directions. And that's the equation. That's the graph of the line that the equation represents. Let's look at another example. Here we have example 4. Example 4 asks us to graph the equation 4x plus 3y equals 7. In other words, graph the line 4x plus 3y equals 7. So we'll do that in the same manner that we did our previous equation. So we have 4x plus 3y equals 7. In the last couple of problems, we solved for y first. I'll probably do that again. Now, some of you may ask, well, why not solve for x first? Could we have solved for x and then plugged in values for y? Well, sure, you could have. It is perfectly fine to solve for x. In fact, I might do that in this case. In this case, I would, if I solve for x, I would subtract 3y from both sides, giving me 4x equals negative 3y plus 7. And if we divided both sides by 4, I'd get x equals negative 3/4 times y plus 7 over 4. And in this case, I would probably want to plug in a value for y. So let's take y of, for instance, 2. And I would take negative 3/4. Let me write it down. I would take x is equal to negative 3/4 times y plus 7 over 4. And I'd put in the y value of 2. And in that case, it would generate an x value. Negative 3/4 times 2 plus 7/4 gives me 0.25, or 1/4 if we're dealing with fractions. So it is perfectly okay to solve for x and then plug in numbers for your y if you like. Typically, people don't do that. Typically, people solve the other way. Typically, people solve for y because there's something called the slope-intercept form. If you were to solve for y, you would subtract 4x from both sides. And then divide both sides by 3. And then you would notice that if you plugged in an x of 0.25, you'd get a y value of 2. I think I'm going to deal with it this way. I think I'm going to deal with the y equals negative 3/4 x plus 7/3, because that's the typical way people deal with it. People usually solve for y because now my line, as we'll see in the next video, is in slope-intercept form. So if you plugged in a 0.25 for x, you'd get a 2. If we plugged in a 0 for x, well, let's plug in a 0 for x and see what we get. Negative 4/3 times 0 plus 7/3 becomes 7/3, which is approximately 2.33. So that's a point, 0, 2.33 roughly. Let's plug in a 1. Negative 4/3 times 1 plus 7/3 gives me a y value of 1. So when I plug in a 1, I get out a y value of 1. Plug in a 1 for x, I get a y value of 1. What are some other things? We haven't plugged in a negative yet, so let's plug in, let's say, a negative 2, for instance. Negative 4/3 times negative 2 plus 7/3 becomes a positive 5. So we get the 0.25 on our line. Or did I say 2? Excuse me. -2.5 on our line. And then let's plug in something a little bit bigger. Let's plug in 5. We'll plug in a 5. So I'll plug in 5 for x. See what I get for y. -4/3 times 5 plus 7/3 is a negative 4.33 approximately. Or if you were looking for fraction form, that's -13/3. So -13/3, which is approximately -4.33. Okay, so that gives me another point. Now I have a bunch of points that I can go plot. On my graph. So let's go ahead and do that. So here we have our 5 points, 0.252, 0, 2.33 roughly, 1, 1, -2.5, and then 5, -4.33 roughly. We have to, sometimes it's not as fun when we graph with these decimals. These aren't too bad, but sometimes it's not as fun graphing with decimals in your x and y values, because we usually assume these grid lines are in increments of 1, but that's what we'll do. So 0.252 as our first point, 0.252 is about right here. 0, 2.33 is about here. 1, 1, that's an easy one right there. -2, 5, I get a point right there. And then 5, -4.33 is about right there. So as you can see, when you don't have nice whole numbers, when you don't have nice whole numbers, it's easier to put the points in. But we can still see the pattern. So let's go with the line through all those points. And obviously, I always like to draw the arrows at the end of both lines so that we can see that the pattern goes on forever. So this example wasn't very much different than our last example, except that we had some more ugly decimal places that we were graphing. Sometimes we can avoid that. Sometimes it's harder to avoid. Let's do one more example. Here in example 5, we want to graph 4 times the quantity x minus 2 plus 2 times the quantity 4y plus 6 equals 12. Now this is still a linear equation because our x's and y's are being raised to the first power, and we are not dividing by x and not dividing by y. So it is still linear, and we can graph this just like we graphed the others. Here's our equation. Let's simplify that. Obviously, if you wanted to, you could plug in a value for y and or a value for x and solve for the other variable, but it's going to be probably easiest if we simplify this first and then solve for either x or y. The distributive property would give me 4x minus 8 plus 8y plus 12 equaling 12. Combining like terms on the left-hand side gives 4x plus 8y equals, oh, excuse me, plus 4 is equal to 12. So what I'm going to do is I'm going to subtract 4 from both sides. That'll give me 8. I think I'll solve for y. That's the typical thing. So I will also subtract 4y from the left-hand side and subtract 4, excuse me, I will subtract 4x from the left-hand side and then also subtract 4x from the right-hand side. Dividing both sides by 8 yields y is equal to negative 1/2 times x plus 1. So this original equation has the same solutions as this equation. That means I'm going to take y equals negative 1/2 x plus 1 and start plugging in various values for x. The first value that I'll choose is a negative 2, and then I'll list out all the values I'll use. Let's use 0, and then we use a positive 2, and then we use maybe a negative 4, and then maybe a positive 4. Actually, since we let's go in order just to make it nice. Negative 4, negative 2, 0, positive 2, positive 4. I'll plug in all those different values for x. When I plug in an x value of negative 4, negative 1/2 times negative 4 plus 1 becomes a 3. When I plug in a negative 2, negative 1/2 times negative 2 plus 1 becomes a positive 2. When I plug in 0 for x, my y becomes a positive 1. When I plug in 2 for x, my y value becomes a 0. And when we plug in a 4 for x, my y value becomes a negative 1. So I have these 5 points that I can plot now. So let's go ahead and plot those points. Here's the grid that I'm going to plot on. So let's take the point negative 4, 3, negative 4, move left 4, up 3, negative 2, 2 gives you this point. 0, 1 gives you this point. 2, 0 gives us this point. 4, negative 1 gives us this point. And therefore, my line looks like this. Again, I like to draw arrows at the tips of those lines to indicate that the pattern goes on forever to the right and forever to the left. So that line, remember, represents all of the solutions to the linear equation that we started with. So that line represented all of the solutions to this linear equation. And every single point on that line, if you plugged it into this linear equation, would give you a true statement. So that's the table method. Again, the table method is also called the finding points method using others. I just like to draw a table, so I call it the table method. We essentially just find some points. We plot those points on the grid, see the pattern, and based on that pattern, we draw the corresponding line.